This is Secondary 1 Honors Quarter 4 video number 3, and this video is on subtracting vectors graphically. There are 3 methods that I'm going to show you how to subtract your vectors graphically. You can also do them without the graph, but on your test you'll be required to show that you can do these using a graph. So the first method that we're going to do is we're going to take our vectors and we're subtracting. And we're going to do this basically in a tail-to-tail fashion, except it is different than when you add. When you add, remember when you do tail-to-tail, you are going to make a parallelogram. You do not do that when you're subtracting. So the first thing we're going to do is put those down tail-to-tail. You really have to pay attention to whether you're subtracting or adding, or else this will mess up. Okay, you put them down tail-to-tail. Now, like I said, when you're adding, you make a parallelogram, but when you're subtracting, you do not. When you're subtracting, you're just going to join your two ends and make a triangle, but the direction that you do it is crucial. You have to make sure that you do this in the right method. Now when you're adding and you do head to tail and you make your triangle, you start at the beginning vector, but when you're subtracting, you're going to, since B is second, you're going to start with B, and that's where you begin your resultant vector, and it's going to go in that direction. Obviously, if we were thinking north, south, east, west, this is in a southwest direction. If you did it in the wrong direction, that's a northeast direction, which is very different. So it's very important that you remember that when you're subtracting these vectors, that you start at the end of the second vector and you go towards the first vector to get your resultant. Okay, before we do the second two methods, they are based on the idea that subtracting is the same as adding the opposite. So if you remember back in when we learned how to subtract integers, we've got 8 minus 5 is the same as 8 plus negative 5, so that's 3. 10 minus 6 is the same as 10 plus negative 6, so that's 4. And 12 minus negative 6 is the same as 12 plus positive 6, so you change that second sign. That's too small for me to work on. You don't just change the plus sign, but you also have to change that second sign, and so it's 12 plus 6, and so that's 18. And so understanding that idea, we're going to use that to subtract our vectors as well. Okay, the next two methods with subtracting vectors, they're based on the idea of adding the opposites, but they're also similar to adding, because that is what we're going to be doing essentially. So the first thing, we're going to take these two vectors, a minus b, they're the same two vectors we had in the previous example with method number 1, so our resultant should be the same. And we are going to, before we do anything else, we're going to change this to an addition problem, and so we're going to add the opposite. And so if you remember back in our first video when we talked about scalars, when you change vector b to negative vector b, it just changes the direction. So you notice that I changed this to a red arrow because now it's going in the opposite direction of what it was before. Okay, so what I did was I changed the subtraction to an addition, and I changed the second one to its opposite, so it's going the opposite direction. Now that you've done that, all you have is you have an addition of vectors problem, so you just do this just like you do adding vectors. So if we were to do tail-to-tail method, I'm going to put the A vector down, same direction, and then the B vector down with their tails touching, so right there at that initial point. And then because it's tail to tail and we're adding, we're going to make our parallelogram. And then my resultant will be going in, as the diagonal. So that's what we're going to do. And you'll notice that this resultant vector is in the same direction, the same length as the one from our method 1. If it wasn't, that would be a really good clue that you did something wrong. Okay, the third method is we're still going to do the same thing as far as changing that to an addition problem and changing it to the opposite right there. So we're going to add the opposite. The difference is now we're going to do the head to tail method. So we're just adding head to tail. So put your first vector, vector A down, and then vector B just at the end of that. Now again, because we're adding, that is different than subtracting. So we're just going to close this triangle, but remember that when we add, we start at the beginning vector and go to the end vector. If you went the other direction, that's obviously going to be a different vector. And so that's the same resultant that I got for the other two methods. Same problem, same result. If you did the same problem and got a different result, that's an indication that you've done something wrong. Okay, we can also do the same thing but using a grid. And so we're going to take our components which we've worked with components before, and we're going to subtract those, but we're just going to put them on a grid so that we can tell where the components are. So if I just start somewhere and say 4, 1, so I'm going to go over 4 and up 1. Okay, that's my first vector. And I'm going to subtract my second one. Now when I subtract them, and I literally just subtract them, I always do tail to tail. And so I'm going to start here at the same initial point, and I'm going to go over 2 and down 3. And then when I do tail to tail and subtraction, I start at my ending of my second vector and I go towards the first vector. So if I was going to do my components, that would be 2, 4. Okay, we're going to take the same two vectors and we're going to subtract them, but we're going to use the other two methods. So if I go to this other one, the first thing that's very important that you're going to do if you're using method 2, which is adding the opposite, and we're going to use the parallelograms, it's very important that you take these two vectors and you change that to adding the opposite. So I'm going to write that as 4, 1 plus, and then I'm going to change these to the opposite, -2 and +3. Now just proceed as just you're adding the vectors. So first I'm going to do tail to tail. So I'm going to start with 4, 1. And then I'm going to do -2, +3. And since we're doing tail to tail and we're adding, we are going to make a parallelogram. You want to make sure as you make this parallelogram that your slope is the same as it was down here. So over here I went up 1 over 4, so I'm going to go up 1 over 4. So you need to make sure that that's the same, and then you do your resultant as your diagonal. So that should look the same as it did in 9a because you're doing exactly the same problem. Okay, in 9c we're going to do the same thing. So again we're going to change that to adding the opposite. Okay, and this time we're doing head to tail, so I'm going to start at a point and go over 4, up 1, and then at the end of that I'm going to go -2 and up 3. And then since we're adding head to tail, I can just close my triangle, but since we're adding, we start at the beginning and go towards the end. So you have to make sure you know, are you adding or subtracting, and if you are not sure, then you need to back it up with another method to make sure you're getting the right resultant. So our components here, if I start here at the initial point and end up there, I'm going to have components of 2 and then 4, which is the same thing I had before. Okay, we'll do one more example here. And you are going to do method 1, and that just means we're going to subtract them, so we're just going to do tail to tail, so just pick a place to start. And so over 4 up 2, there's my first vector, and then -3, +6, just barely made it. If you start out and you run out of room, you might just want to erase and just readjust. Okay, now since we're doing tail to tail but we're subtracting, we're not doing a parallelogram, I'm going to start where I ended and go towards the beginning, and that's my resultant vector. So if I wrote the components of that, which you're not going to have to write the components unless you're specifically asked to do it, so if I just ask you to show me graphically, then you don't have to write the components. But it is a good way to check. So my components are 7, -4. Now let me show you how to do this without a graph. It's really, really easy without a graph. You can just take your two components right there, and 4 minus -3 is 7. And then 2 minus 6 is -4. And so you might think, wow, that's really easy. How come we have to do the graphs? Well, one thing about the graphs is it helps you understand how the vectors work together. But that is also something that you need to know how to do. So you're going to have to show me that you can add and subtract graphically, but you can use this component idea to just check and make sure that you're doing it right. So method number 2, we're going to take the same problem and we're going to add the opposite. So first I'm going to write that as adding the opposite. Change the -3 to a +3, the 6 to a -6. And now we're going to do the method tail to tail. So we're going to start somewhere and go 4, 2. And then we're going to start at the same place and 3, -6. Okay, since we're adding and we're doing tail to tail, that means parallelogram. So I'm going to make sure I get the same slope. So if I start here, I'm going to go up 2 and over 4. And then I'm going to close that parallelogram. Oops, right there. That's why we check. So as long as you know where your corner is, that's really what you need to know for the parallelogram method. And so that's going to be my resultant vector. Now if you compare it to the resultant vector we got in 10a, that looks the same direction, same length, but I can always check it by using the components. So if I start here and I go right here, what are the components of that vector? 1, 2, 3, 4, 5, 6, 7, -1, 2, 3, 4. So it's 7, -4, and those are the same components I had before, so you can check that and make sure it's the same. Okay, the third method, again we're going to start with adding the opposite. Okay, and so I'm going to first put the 4, 2. And this time I'm doing head to tail. And so starting here, I'm going to go over 3 and down 6. Now since I'm adding, remember we started at the beginning and put our vector down like that. So you're going to have to practice this enough that you are comfortable and you know which way to draw that resultant vector, or else you probably will make mistakes. But if you remember that you always have a backup and you always have a way to check this, then you shouldn't miss any of these problems. Okay, that will take care of the secondary one, video number 3. You are now prepared to do problems 16 through 21 on your worksheet, and then you'll do video number 4. You will have to show 2 different graphing methods for each problem, so at least 2. You can always do 3, but you have to show at least 2 graphing methods.